The graph of linear equation into two variables is a straight line, which means that the points or coordinates contained by this line are the solution to the given equation. These are the values of x and y that will make the equation true. What if it is an inequality into two variables? What is the difference of each graph? How do we determine its solution? Just stick around and have fun, for in this video, we will be discussing linear equation versus linear inequality. If you are new to this channel, kindly hit the subscribe button and the notification bell, and I promise that I will journey with you in learning math lesson in an easy way. Linear equation to two variables versus linear inequalities. The concept of equations and inequalities can be best illustrated through a weighing scale. So in the first diagram, this illustrates an equation because the left side is equal to the right side of the equation. When the left side is greater than the right side or the right side is greater than the left side, this illustrates linear inequality. This is the form of linear equations into two variables, ex plus by is equal to c, where a, b, and c are all real numbers. In linear inequalities into two variables can be illustrated into four different forms. First, ax plus by is greater than c, or it can be ax plus by is less than c, or it can be ax plus by is greater than or equal to c, and ax plus by is less than or equal to c. And these are our objectives. After watching this video, you are expected to be able to define a system of linear inequalities, graph a system of linear inequalities in two variables, solve problems involving systems of linear inequalities in two variables. Suppose we have the linear equation x minus y is equal to 0. So the graph is a straight line. All the points that contained by this line are the solutions to this linear equation. Suppose we have this point 1, 1. So if this is 1 minus 1, so it's equal to 0. So it satisfies the given equation. Suppose we have also this point. So 2 minus 2 is also 0. Then 4 minus 4 is also 0. And negative 1/2 minus negative 1/2 is also 0. So indeed, all the points that are contained by this line are the solutions to this linear equation in two variables. Linear inequalities. Suppose we have the inequality x minus y is greater than 0. The points in the shaded region are the solutions to this inequality. X minus y is greater than 0. So suppose we will pick a point in this region. So suppose we have this point 5 and 2. So let's try to check whether these coordinates satisfy this given inequality. So x is 5 minus 2. So that would be 3 greater than 2. So indeed that is true. Let's try another point. Suppose we have a point here. This is 1 and negative 1. So if 1 is x, negative times negative 1 is positive 1. So 1 plus 1 is 2, and 2 is greater than 0, so still that is true. Let's try another point that fall along the y-axis. This is 0 and negative 6. 0 minus negative 6, negative times negative becomes positive. So 0 plus 6 is 6, and that is greater than 0. Still, that is true. So all the points that can be found, that can be located in the shaded region are the solutions to this given inequality. Let's try to check a point outside this shaded region. For example, we have 2 and 6. So let's plug it into the given inequality. So x is 2 minus 6 greater than 0. 2 minus 6 is negative 4 greater than 0. So negative 4 is less than 0, so therefore this inequality is false. So in other words, all the points that can be found in this unshaded region are not the solution to this given inequality. So the solution of the linear inequalities into two variables is a half plane. How do we know which half plane will be the solutions of the given inequality? We can do it by graphing linear inequality. How to graph linear inequalities into two variables? So these are the steps. First, you're going to change the inequality sign or symbol into an equation. Then graph the linear equation obtained in step number 1. This will be the boundary line. If the given inequality symbol is greater than or less than, draw the boundary line as the broken line. If the inequality symbol is either greater than or equal to or less than or equal to, draw the boundary line as a solid line. Then decide which half plane contains the solution set. How do we know? We will pick a test point in one side of the boundary line. For convenience, you will use the origin or the 0, 0. So you will replace the variable x and y in the given inequality and try to check if it satisfies the given inequality. So if the resulting inequality is true, you will shade that region that contains the test points. Otherwise, shade the other side of the boundary. Let's try to graph example number 1. 2x minus y less than 4. So, this is our given inequality. First step, we are going to change this inequality sign into an equation. And we will graph the equation. So, in graphing linear equation into two variables, we can do it by table of values. We can do it by slope-intercept method. And even we can do it using intercepts method. For convenience, we will graph the linear equation by intercepts method. In graphing linear equation by intercept method, we will have to know the x-intercepts and the y-intercepts. And the x-intercept is the value of y when x is equal to 0. Similarly, the y-intercept is the value of y when x is equal to 0. So, letting y is equal to 0, we will be solving for the x-intercept. So, this would be 2x minus 0 is equal to 4. Then, divide both sides by 2 to solve for x. So, our x is equal to 2. And this will give us the coordinate 2 and 0, which is our x-intercept. Solve for the y-intercept. Let x is equal to 0. Substitute. So, 2 times 0 minus y. So, this would be negative y is equal to 4. The coefficient is negative 1. Divide both sides by negative 1. So, our y is negative 4. This will give us the coordinate of the intercepts, which is 0 and negative 4. So, the intercept of the line 2x minus y is equal to 4 are the points 2, 0 and 0 and negative 4. So, if we have this Cartesian plane, locate first the x-intercept. So, this is 2 and 0 and negative 4. So, it could be here. Now, the given inequality, the symbol is less than. So, if it is less than, in the step, you will draw a broken line. This will serve as the boundary. The line will divide the plane into two half planes. So how do we know which of these two halves will be the solution set to the given inequality? So we have to use the test point. For convenience, we will make use of the origin. Why? Because if this is 0 and this is 0, so 0 minus 0 is 0 and 0 is less than 4. 0 less than 4 is true, so therefore, we will shade that point that contains the test points, which is the origin. So all the points that lie in this shaded region are the solution to the given inequality. Then let's try to check it out. Suppose we have to choose this point that is outside or the other side of the boundary. So 5 and 2. So if we will substitute 5 to x, so this is 2 times 5 minus y, which is 2 less than or equal to 4. So 10 minus 2 is 8 less than 4. So 8 less than 4, this statement is false. So that is why the points that can be found here are not the solution to the given inequality 2x minus y less than 4. 3x plus 2y is greater than or equal to 6. So again, we will change the equation, the inequality sign into an equation. And we will graph this equation 3x plus 2y is equal to 6 by intercepts method. So let y is equal to 0 and solve for x. This would be 3x plus 2 times 0 is equal to 6. 3x is equal to 6. Divide both sides by 3 to solve for x. Our x is equal to 2. The coordinate is 2 and 0. Solve for the y-intercept and let x be equal to 0. So 3 times 0 plus 2y is equal to 6. So this would be 2y is equal to 6. Then divide both sides by 2 to solve for y. Then our y is equal to 3. The coordinate of the y-intercept is 0 and 3. So therefore, the intercepts of 3x plus 2y is equal to 6 are the points 2, 0 and 0, 3. So if you have this Cartesian plane, plot the 2 and 0 and the 0 and 3. The given inequality is 3x plus 2y greater than or equal to. So that would mean that our line is a solid line. So again, the solid line divides one plane into two half planes. So which of these two halves is the solution? We will check using the test point, the origin. So this would be 0, 0. So this is 0 and this is 0. Then 0 greater than or equal to 6. This statement is false since the half planes that contains the test point is false. So we will shade the opposite region. So therefore, this is the solution to the given inequality. So if the inequality symbol is greater than or equal to, the points that contained by this line are also solutions to the given inequality. Let's try this point, which is 4 and negative 3. 3 times 4, the value of x, plus 2 times negative 3, which is the y, is greater than or equal to 6. So 3 times 4 is 12. Then 2 times negative 3 is negative 6, greater than or equal to 6. 12 minus 6 is 6, greater than or equal to 6. So this statement is true. So therefore, the points that contained by this line are also part of the solution set. So that's the difference between the inequality that has equal to at the bottom. Let's graph example number 3, negative x plus y less than 2. So change this one into an equation. Graph this one using the intercept method. So let y is equal to 0 and solve for x. So negative x plus 0 is equal to 2. So this is negative x is equal to 2. The coefficient must be positive 1. So divide both sides by negative 1. So our x is 2 divided by negative 1 is negative 2. This will give us the coordinate of the x-intercept, negative 2 and 0. Solve for the y-intercepts. Let x be 0. So this is 0 plus y is equal to 2. 0 plus y is equal to 2. And our y is equal to 2. The coordinate 0 and graph the x-intercept. The y-intercept is 0 and positive 2. The given inequality is less than, so therefore the boundary line is a broken line. So test using the test point if this region satisfies the given inequality. So if this will be 0 and this will be 0, so 0 less than 2. So this statement is true, so therefore we will shade this region. Example number 4. Ben has two part-time jobs, one paying 30 pesos per hour and another paying 35 pesos per hour. He must earn at least 825 pesos per week to pay his expenses whilst attending college night classes. Write an inequality that shows the various ways he can schedule his time to achieve his goal. So we will now let x be the number of hours Ben works for the first job, and we will now let y the number of hours Ben work for the second job. So the hourly rate for the first job times the number of hours worked on the first job plus the hourly rate of the second job times the number of hours worked on the second job is at least 825 pesos. So the rate for the first job is 30 times the number of hour work on the first job represented by x plus the rate of the second job is 35. The number of hours for the second job represented is y. So take note, at least is minimum. That symbol that we are going to use is greater than or equal to. If it is maximum, the symbol that we are going to use is less than or equal to 825. So simplify. So this will be our inequality to represent the condition of the problem. Now let's graph the inequality 30x plus 35y is greater than or equal to 825. So that we will know how can possibly Ben arranged his schedule. 30x plus 35y greater than or equal to 825. Change this one into an equation. So we will grab this equation using the intercept method. We will now let y equal to 0 and solve for the x-intercept. So 30x plus 35y is equal to 825. Then 30x plus 35 times 0 is equal to 825. So 30x is equal to 825. Divide both sides by 30 to solve for x. So this is 27.5, the x-intercept. Solve for the y-intercept. Let x be equal to 0. So this is 30 times 0 plus 35y is equal to 825. So 35y is equal to 825. Divide both sides by 35. So that would be y. Approximately, that is 23.57. Plot them in the Cartesian plane. So this is our y-intercept, 0 and 23.57. Our x-intercept is 27.5 and 0. So the given inequality is 30x plus 35y is greater than or equal to 825. So our boundary line is a solid line. So we will determine which region will satisfy the given inequality using the test point, which is the origin. So if this will be 0, so this would be 0, then 0 is greater than or equal to 825. So this statement is false. So therefore, we will shade the other region. The points that can be located here are the combinations of the possible schedule of Ben so that he can earn at least 825. Suppose Ben will work 15 hours in the first job and work 12 hours on the second job. Let's try to find out how much will he earn. This can be located in this region. So let's substitute it to the given inequality. So this is 30 times 15 plus 35 times 12. The value of y is greater than or equal to 825. 30 times 15 is 450. 35 times 12 is 420, is greater than or equal to 825. 450 plus 820 is 870, greater than or equal to 825. So indeed, Ben satisfies the given conditions that he will earn at least 825, satisfies the given condition. Example number 5, George is selling ice cream cones at a school fundraiser. He is selling two sizes, a small which has 1 scoop and a large which has 2 scoops. He knows that he can get out a maximum of 70 scoops of ice cream out of his supply. Now we will write an inequality that shows various of ways he can choose the type of cones. So we will now let x be the number of small cones and let y be the number of large cones. The maximum number of scoops he can give is 70. So this would be number of scoops times the number of small cones plus the number of scoops times the number of large cones. Maximum is at most 70. Write this in inequality. So 1, the number of scoop for the small cones times the number of small cones plus 2 for the large cones times the number of large cones. At most, maximum is less than or equal to 70. Simplify, so this would be x plus 2y less than or equal to 70. Now let's graph this inequality, x plus 2y less than or equal to 70. First, we're going to change this inequality sign to equation, and we will graph this using the intercept method. So let y be equal to 0 and solve for the x-intercept. So this would be x plus 2 times 0 equals 70. So this would be x is equal to 70. So our x-intercept is 70 and 0. Let's solve for the y-intercept. Let x be equal to 0. So this would be 0 plus 2y is equal to 70. 2y is equal to 70. Divide both sides by 2 to solve for y. Our y is 35. So therefore, our y-intercept is 0 and 35. And the intercepts of the line are 70, 0, and 0, 35. Plot this in the Cartesian plane. So this is our x-intercept, and this would be our y-intercept. So as you can see, our shaded region is below the boundary line. So why? Because if we will try to check the origin the coordinate of the origin in our given inequality, x plus 2y less than or equal to 0. So this would be 0, 0. So 0 plus 0 is 0, less than or equal to 70. So this statement is true. And also, notice that our boundary line is a solid line because the given inequality is less than or equal to. Take note that x and y represent the number of cones. So since the number of cones cannot be negative, we will choose only part of the shaded region to represent the possible ways that Ben can possibly choose for the number of small and large cones respectively. So these are the region that will represent the solution to this given inequality. And let's try to find out one point that can be found here. Suppose we have this coordinate. So this is 10 and 20. Let's plug it into the given inequality. So this would be 10 plus 2 times the value of y, 20 less than or equal to 70. So this is 40. 10 plus 40 is 50 less than or equal to 70. So the statement is true. So in other words, the possible combinations that Ben could possibly have, x and y, that can be found in the shaded region.
If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share our videos so that I will be able to help you learn math lessons and concepts in an easy way. See you in our next video. Thank you for watching.